Welcome back, guys. We're going to be taking a look at the inverse tangent function. So to do that, we're going to first graph the tangent function. If you remember, the tangent function has vertical asymptotes at odd multiples of pi over 2. Let me draw a few more. Heck, let's draw one more. And if you remember, the graph of the tangent function looks something like this. The period of the tangent function is pi. In this case, my domain would be all real numbers except odd multiples of pi over 2. And my range would be all real numbers. It's a little review of graphing the tangent function. Now, to graph the tan inverse function, once again, we're going to be restricting the domain, where we're going to restrict the domain between negative pi over 2 and pi over 2. It's just looking at one cycle of tangent. And what we're going to do is we're going to reflect that across the line y equals x. When we do that, what's going to happen is we're going to end up with two horizontal asymptotes now. One at pi over 2 and the other at negative pi over 2. And your graph will look something like this. And that's your graph of tan inverse. So the domain of the inverse tan function is negative infinity to infinity. The range is between negative pi over 2 and pi over 2. But one thing you should notice here is that I have parentheses around both of them. If you remember, for the range of the inverse sine function, negative pi over 2 and pi over 2 were both included, right? So we included brackets there. But just watch out here, for the inverse tan function, we'll have parentheses, not brackets. And so keep this in mind as we're doing different problems. So what does it mean when I say y equals tan inverse of x? That's the same thing as saying that tangent of y is equal to x. And again, here we say that x is between negative infinity to infinity, which just means x is all real numbers. And then y has to be between negative pi over 2 and pi over 2. So when you take tan inverse of a number, you have to make sure that your angle is between negative pi over 2 and pi over 2. So let's go right into our first example. Here I have tan inverse of negative 1. So just like we've been doing before, I know that tan inverse of negative 1 is some angle. And what I know about this angle is that if I take tangent of that angle, I'm going to get negative 1. And also that angle has to be between negative pi over 2 and pi over 2. And so again, hopefully you're familiar with your unit circle or you're familiar with your reference angles. In this case, I know that tangent of pi over 4 is 1, right? Pi over 4 will be the reference angle for theta. And because tangent of theta is taking a negative value, I know we have to be in quadrant 4. So what that tells me then is that theta must actually be negative pi over 4 radians. And that's my answer. So again, you got to make sure that when you find the inverse tan of any value, your angle must be between negative pi over 2 and pi over 2. Number 2, here we have inverse tan of root 3 over 3. In this case, because I'm looking for an angle theta, such that tangent of theta is a positive value, root 3 over 3, I know that we're in quadrant 1. And if you remember your acute angles, that angle would be pi over 6. If you ever forget, you can always go back to your 30-69 triangle, and then you can ask yourself, tangent of one angle gives me root 3 over 3, and that would be 30 degrees or pi over 6 radians. At this point, I want you to try number 3 on your own. As usual, pause the video, and when you're ready, press play. So here we want to look for an angle theta, right? Such that tangent of theta equals to negative root 3. And we know that theta is between negative pi over 2 and pi over 2. So hopefully you get this idea that when you're taking the inverse tan of a number, you're looking for the angle, right? You're like working backwards essentially. So tangent of one angle gives me negative root 3. First off, my hope is your angle is in quadrant 4, because we know tangent takes on negative values there. And if you also remember, tangent of pi over 3 is equal to root 3. And so if my angle is in quadrant 4 and it has a reference angle of pi over 3, I know that it looks something like this, if you want to just kind of picture what this angle looks like. I know my reference angle is pi over 3, but because I'm in quadrant 4 And because I want to be between negative pi over 2 and pi over 2, I'm going to be going clockwise pi over 3 radians, and so my angle is negative pi over 3. So what that tells me then is that my final answer is negative pi over 3. So hopefully you're able to get that correct. If you didn't, learn from your mistakes moving forward. The last thing we're going to look at are, again, these properties are very similar with all the ones we've done already. So when I see tan of tan inverse of x, this is going to equal to x, where x has to be between negative pi over 2 and pi over 2. And then for this one, where tangent of tan inverse of x will always equal x for any real number. So looking at number 1 here, I have tan inverse of tangent of pi over 6. This is just equal to pi over 6. And the reason why is because pi over 6 lies between negative pi halves and pi halves. That's it. And so all we're doing is making sure that our angle is between negative pi halves and pi halves. Now if you look at number 2 here, pay attention to 2 pi over 3. That is not an angle between negative pi over 2 and pi over 2. So there's actually a couple ways you can do this. One way is you can always do it by brute force. You can first figure out what is tangent of 2 pi over 3. Right? What is this equal to here? And so if you remember your unit circle or your reference angles and all that, you can do it that way. And what you should end up with is root 3. Negative root 3, right, since we're in quadrant 2. And then from there you can say, okay, tan inverse of negative root 3, that's equal to some angle theta, where tangent of theta is negative root 3. And if you do this very carefully, you'll end up with the fact that theta must equal to negative pi over 3. The other way you can do it is note that if you remember, tangent has period pi. So what that means then is that it repeats every pi, right, every interval pi. So tangent of 2 pi over 3 would also equal tangent of 2 pi over 3 minus pi, which is tangent of negative pi over 3. And negative pi over 3 falls between negative pi halves and pi halves. So there's a couple different ways you can go about this, but make sure you understand all your trig ratios, all your unit circle values. So at this point, I'm going to let you try number 3 and 4 on your own. And as usual, when you're ready, press play. Now for this one, negative pi over 4, this is an angle between negative pi halves and pi halves. And because it is, you're done. In this case, it's just negative pi over 4. There's really no work to be done here. Now for number 4, it's tangent of tan inverse of 1024. And because in this case, you can take any real number here, my final answer will be 1024. And in this case, for number 4, we're looking at this here. Right? So again, make sure you note the domain and range of the inverse tan function. In particular, it's the range that you really have to watch out for. So just make sure you understand what we're doing when we're computing inverse tangent of some number. Right? We're looking for an angle between negative pi over 2 and pi over 2, such that tangent of that angle gives you that number. Okay? So again, you want to think of it as like a reversal, right? So guys, this is the end of section 7.1. Make sure you understand your inverse trig function as well. In the next video, we are going to continue this discussion with inverse functions for secant, cosecant, and cotangent. All right, guys, have a good rest of your day.